Hello and welcome to Through the Telescope, the podcast that puts the lens on astronomy. I'm Rose Waugh and I'm an astrophysicist and science communicator.
And I'm Elliott Bruce, and I'm neither of those things, but I'll be trying to find out why we should even care about astronomy. We'll be exploring some of the big topics in the field in little manageable pieces and have some fun along the way.
So, whether you know your red giants from your redshifts, or you're not quite sure what the difference between astronomy and astrology actually is, join us as we launch ourselves into the cosmos and try not to burn up on re-entry. Through the Telescope is sponsored by Pic Astro, the astronomy and astrophotography image sharing app, dedicated to your images of the cosmos no matter what stage you are on your journey around the universe. No ads, spam, or fake accounts.
So, Ro.
So, Al.
It's a big week this week.
Big week, big things.
A couple of days ago, you have submitted your thesis, so you're on the way to being Dr. Rose.
Hopefully.
Yeah. So you've got a few things before you are Dr. Rose, but... You know.
Yeah. It's submitted. My examiners will read all however many pages it is. 73,000 words. And hopefully they won't hate it too much or find too many holes in it. And then I'll have to do my viva, which in the UK is an unknown length of time in a room with two people grilling you about everything you've written in your thesis.
Yeah. But at least you don't need to cook for anyone.
That's true. Is that France?
Yeah, there was somebody I knew that did their PhD in France, and they not only had to give a public presentation, they also had to cook for their examiners. I'm not sure if also for other people. So they spent the night before not like preparing for anything other than cooking all of the food and stressing about feeding everyone.
Yes. Doesn't really make any sense.
No.
At all.
No.
Also, if I was an examiner, I'm not sure I would necessarily just want, like, random person cooking things. I don't know.
I know.
A bit strange. It is strange, though, how whilst, you know, a PhD is a PhD, if you do it in any kind of country around the world, at any university, there are variations, but the idea is the same. Of you do research, you hopefully write some scientific papers that get peer-reviewed and published, and then once you've done enough of a body of work, you get a PhD. The way of examining them really does vary a lot from country to country.
Yeah.
You know, whether that's giving a public lecture, whether that's, you know, sitting in a room for... You literally don't know how long until they get bored of talking about your science.
Yeah.
So that could be like 2 hours.
Yeah.
It could be 8 hours. Not even joking.
Well, I've heard of some people who they've gone for their viva and one of the examiners has been like, I need to go to the gym, so let's just wrap this up now.
Yeah.
Which sounds pretty ideal, to be honest, but
yeah,
from a stress of being examined point of view, but
yeah, it varies a lot from country to country.
And it also, I remember being around people who are within a group where somebody's sitting their viva and they're like, we're waiting for this person to come out because then we can have celebrations. Like, they've been in there for how many hours, then they see a glimpse of them. Like, oh, are you done? Like, no, we're just breaking for a snack and a toilet because maybe halfway through, I don't know how much longer we're going to have. Like, okay. Put the balloons back, guys. Yeah.
Yeah.
It is quite weird how... I don't know if there's any other sort of situation in education where it's like, you have an exam, it lasts an amount of time, less than 24 hours. So...
Oh, that's all right then.
Yeah. Unless they're like, sorry, we've got to break
I
for a
just
nap.
have so many questions. Yeah, okay, right. Yeah. Anyway, that's the future.
That's the future.
Hopefully
the main
not 24 hours.
The main thing is you've submitted your thing and you've not yet heard back from anybody in admin saying that you've submitted it incorrectly, so that's good.
Yeah, encouraging, because as with anything in life, the online forms associated with these things are an exam in themselves.
Yeah.
And I think people do get it wrong all the time, and I'm expecting to be one of those people.
It doesn't help, though, does it, when you have at least 2 different documents that are both supposedly current, given that they're both on a website that the university has, that give different...
Contradictory advice on how to submit your thesis.
Yeah.
Yeah, that didn't help me.
No.
But
I don't know why someone would think it would, but...
Anyway, let's talk about some science.
Okay. Well, let's start off, first of all, with a listener question. So, why are we able to see the latest supernova in Messier 101? Do you call it Messier, or do you just call it M101?
Either.
I'm going to call it Messier 101, which is the Pinwheel Galaxy.
It is indeed.
In real time, when it takes 21 million light years for the light to reach us.
Well, it takes light a certain amount of time to get to us from anywhere.
Yeah.
Light has to cover that distance, and it doesn't travel instantly.
Mm-hmm.
So there is a lag associated with any object in the universe. The further away the object is, the greater the lag is, right?
Yeah.
So the Pinwheel Galaxy is obviously pretty far away from us, with a distance of 21 million light years.
Yeah.
So it's not, that close.
Yeah.
But any light that comes from that galaxy is taking a certain amount of time to get to us.
Yeah.
So once the supernova starts, we are not immediately seeing it.
Mm-hmm.
We have to wait for the light to get to us.
Yeah. So we need to wait 21 million years for it to get here. But then...
Which it already has, because we're seeing it.
Yeah. Yeah. So this star is well dead at this point.
Yes. I mean, yes. But it's taking all of the light from that supernova 21 million years to get to us.
Yes.
So the first photon that says the supernova has started,
Mm-hmm.
as if you could get that from one individual photon. But,
Yeah.
It's delayed by 21 million years by the time we see it. But so is the second photon, and the third photon,
Yeah.
and the fourth, etc., etc. So we can still see the supernova happening in real time.
Yeah.
We still see the supernova as if it is happening.
Yes.
It's an accurate depiction of what is happening. It's just delayed.
It's in real time, but it's not instantaneous,
Yes.
as it were. It's like somebody started playing Star Wars A New Hope and you can still watch Star Wars: A New Hope, but they just started playing it 21 million years ago. You know what I mean?
No.
Okay. If you started like beaming a movie from
Right.
the Pinwheel Galaxy
Yes.
21 million years ago, we would still be able to watch the movie because each one of those slides is still
Has
the
been
same.
sent to us.
Yeah.
Yeah.
It's just that each and every one of those slides has taken 21 million years to get here.
Yeah.
So, yeah.
So it's not. We're not watching it live.
No.
It's,
It's recorded live.
It's like, yeah, it's recorded live and you've caught it on your favourite broadcasting, streaming platform.
Yes.
We won't name any names here.
Yeah. Yeah.
I hope that answers the question. I'm not sure if I understood entirely correctly the question.
Hope so. If not, you can always get a follow-up question.
Oh, we love follow-up questions.
Just to also...
I'm getting really good at that now. Kiddo asks me a lot of follow-up questions.
There are a lot of follow-up questions. You think you answer a question and then there's another one right around the corner. You've got to think again.
It's quite similar to meetings with my supervisor, really.
Yeah. Yeah, that's fair. Very similar supervisors and toddlers.
That is actually true. I hope Moira's not listening. She might agree, though, so... It's the enthusiasm.
Yeah.
Yeah.
For anyone interested, the supernova is in the Pinwheel Galaxy, as we said, which is sort of, if you've got the plough or the Big Dipper, it's in the handle bit. Well, it's not in the handle bit. It's slightly above the end of the handle. So if you can see the plough, then you should be able to see supernova if you've got any form of telescope, really. And also it's got a snappy name of SN 2023 IXF.
Mm-hmm.
Just so you know.
In case you want to look it up on the Tinterwebs.
Yeah. Yeah. So I think it'll be around for a little while. So, yeah. Might be worth checking out. But our episode today is about the fourth planet, Mars.
The red planet.
Red planet. All this week, knowing that we were going to record this, I've had War of the Worlds come into my head a few times, unrequested. So,
living rent-free in your brain.
Yes, exactly. But the Martians are not about to invade. But what can you tell us about Mars?
Well, it's about 1.5 AU from the sun.
Okay. Pretty close, really.
Yeah, all in all, that's not really that far away,
We're 1 AU, so...
It's, it's pretty close, really. That corresponds to 142 million miles. 228 million kilometres, for those that prefer kilometres.
Yeah, these are definitely numbers that make more sense in terms of distance of the Earth from the Sun.
Yeah, it's just silly numbers, really. But, sometimes it gives people that, happy feeling when units that they like are used.
Yes.
So, yeah, and, whilst it's pretty close, it's far enough away for a year to be pretty long.
Okay.
687 Earth days for a year on Mars.
Oh, wow.
So, pretty long time.
Yeah.
A day, however, very similar to an Earth day.
Okay.
A Martian day is 24 hours and 39 minutes.
That is remarkably close.
And as I'm pretty sure we've mentioned before, the name for a Martian day is a sol.
Yes, we have mentioned that.
Pretty frustrating. A bit confusing, I think. Really.
I think so.
Yeah, confusing. But very useful. We've had a lot of missions to Mars, particularly with rovers. And so it is helpful to, to define the Martian day by something.
Yeah, a lot of them also use solar panels as well, so it's not even like, it's just sort of nice because it's bright. It's also like, energy is important.
Functionally useful.
Yeah.
To be able to do so. So, yeah, I guess it's another reason why it's quite nice that the days are
pretty similar.
A similar length of time.
Must make work shifts a bit better as well on when you're telling them what to do from Earth.
Well, yeah, this is what I mean, because you can have a shift that doesn't disrupt.
Right. Yeah.
The human sleep schedule. I mean, I guess it does if you're on a night shift. It's still disrupting it, but your body clock is not getting incredibly confused, I guess.
Yes.
Which, obviously, you would want to avoid having that happening at mission control, so you would probably end up needing more people to try and, I would imagine, try and mitigate that kind of thing, which not really an issue for Mars. So
I also found that since people have called, since the term soul was coined, other terms have come up, like yester-sol.
Yes.
Which just kind of neat,
Yeah, I mean, it makes sense. It feels like a similar, I think we mentioned this last time, but a kind of it's the bridging yet again between science and science fiction.
Yeah.
Because there probably are terms like, for example, things like yester-sol that have probably been used in science fiction and then they cross their way over into reality.
And in other...
There's a lot of toing and froing between science and science fiction, which is quite interesting.
In other cases, it goes the opposite way around and gets expanded significantly. So,
So yes, days are quite similar, years are quite different.
Okay. How big is it?
Remarkably small, actually, I think.
Okay.
I mean, I guess everyone's going to have a different opinion based on how they expect Mars to be, but I suppose that there's a part of me that kind of just feels like Mars is kind of similar to Earth, Like there's the 4 rocky planets. Mercury is the small one. That's kind of how my innermost person, I guess, feels.
Yeah.
Actually, Mars is quite small. Its mass is only 10% that of planet Earth.
Well. That is...
And it's about half the radius, roughly.
Okay. Yeah, because... So my inner person, before Kiddo with their TV preferences for all things space came along, I think I probably would have thought Earth was the largest, Mars was similar in size, and then Venus was a bit smaller and Mercury was tiny. As opposed to, what was it, Earth and Venus similar sizes, and then Mars quite significantly smaller, and then Mercury even smaller.
Yeah.
It's interesting. I guess also part of that is just that we hear a lot about Mars because people want to go to Mars.
Yeah.
So it's like, it must be big because it's important. If you know what I mean.
Yeah. Maybe that does play into it. I don't know. I think I just didn't really appreciate it before, to be honest. But Yeah, remarkably small.
So-
About 38% of Earth's gravity.
Okay.
So, people going to Mars would be going to a planet that is considerably smaller, but also is less dense than Earth as well. And that combination leads to quite a significantly smaller gravity.
So we're more than, well, how do we, we're less than half as heavy? We're more than twice as light? I don't know how.
Yes, I don't know how one would describe that, but you would find it a lot easier to jump off the ground.
Another thing that I don't think, when you see pictures of Mars rovers, etc., you don't think, it just looks kind of normal.
Yeah, I mean, I think you see pictures and you don't really get a perspective on things, because even though it's considerably smaller, would you tell the difference in size from standing on the surface? I don't think you would.
You would just look at it and be like, I live on Earth, so everything is Earth-sized. I could imagine standing on that deserty-looking world. It must be like Earth.
Well, I just
Kind of
meant if you were on planet Mars, from the surface of Mars, would you be able to tell that the planet is smaller than Earth?
I wonder if you could tell with
You're not going to be able to
Mercury.
see the curvature.
Yeah.
I don't. You're tiny.
You might have to wait for somebody to, or something, to, like, go across the horizon, if you know what I mean. Because is that not one of the ways that we know that the Earth is round? Sorry, flat earthers, but, like, you see stuff disappear across the horizon.
Yeah, you may very well notice a difference then, but
you're not
that's
gonna...
not what you were talking about.
Yeah,
You said,
yeah.
I see these pictures and it looks just like Earth.
Totally.
I'm just asking, what did you expect? Did you expect to see the curvature from the surface, or...?
I don't know, I think...
It's pretty mountainous as well, really.
Yeah.
It's got lumps and bumps.
And none of the rovers are doing any sort of parkour or anything, and, like, floating down.
Yeah, they don't tend to travel particularly fast.
No.
Temperature-wise, you could be quite happy when it's warm, I suppose. It gets up to 35 degrees C or 95 degrees Fahrenheit.
Okay.
But when it's cold, you're probably not so happy. At minus 110 degrees C or minus 166 Fahrenheit.
That is, yeah, that's a range of temperatures.
Yeah, I mean, it's a less hospitable range than other planets. But, yeah, still, the cold end makes you wince a bit, doesn't it?
Definitely. I was going to say that I had felt lied to when I discovered that Mars was really cold, because I remember as a kid thinking that Mars was hotter because it's red. That's the logic of my kid brain.
Right.
Well, then it turns
there
out
is a logic there.
It's further out and it's colder. But actually, if the highest temperature is 35 degrees, it's not like freezing. I mean, it is. It literally goes down to minus 110 degrees C. But, it's not just cold.
No.
It's also
Yeah.
reasonably hot. I would struggle in 35 degrees. I think most people probably would. But.
Yeah, I mean, especially on Mars when you're just like baking in a desert, you probably would. But, yeah, I mean, it doesn't, as we'll probably talk about later, it doesn't really have much of an atmosphere, really. So that's going to influence it getting cold.
Yes. Yeah.
And if it had more of an atmosphere, it might not feel, it might feel more comfortable. But yeah, as it is, it doesn't have that much of one. It's got a thin atmosphere. and it's 96% CO2, so it's not, it's almost exclusively carbon dioxide. It's not the most attractive of atmospheres.
No.
Has got a little bit of argon, a bit of nitrogen. They don't really do anything though, so
No.
it's it's pretty much only carbon dioxide and not that much of it.
Well, I mean, at least it's not sulfuric acid they're like Venus.
Yeah.
So that's a step up.
Yeah, can't argue with that. It doesn't stink of rotten eggs either, so that's something.
But not breathable. Pre-breathed.
Perhaps with previous owners.
So is it actually red?
Yes.
Okay.
Yes, that's how it got its name. Mars.
'Cause I feel
after
like
the Roman god of war.
in a lot of pictures I feel like it looks brown. Is it like a reddy brown, where some people see it as red and some people see it as brown? Or?
I think it is a reddy brown. Some bits of it are browner than others.
Okay.
But also, one should be aware and cautious with images relating to space.
Okay.
Because often, I don't know how true this is for Martian stuff, but it is not uncommon for photos to have been edited.
Okay. Photoshop.
Yeah. Plonk some aliens on there. Not in that kind of way, just edited in the sense that you have to edit pictures to change the brightness or exposure or whatever so that you can clearly see the features that you want to see.
Yeah.
And, space images of nebula or clouds of gas in space, or the sun, for example, where images are edited and colorized in different ways to make things clearer or for some other meaning. So for example, with the sun, when they take images of the sun and you take a picture, that's fine if it's invisible light. But if you take a picture, you look at the sun and you look at like the UV light that's coming out of it, you can't see UV light.
No.
So when you then take that information that is light and you try to make a photo out of it, you can still do that, but it isn't a photo in the same sense because your eyes wouldn't be able to see that particular thing, right?
You've adjusted it so that you can actually view it.
Yes, and so it then will be typically assigned a colour, so that when people see that image of the sun and the sun is purple,
They go, that's UV.
It's known that has a meaning.
Similarly, if
the image is legitimate, but the colour does not correspond to the sun in that circumstance.
Yeah, and in that case, we're like, we're happy that the sun isn't purple. We're fine with that because we know that the sun doesn't look purple.
Yeah.
But there are other cases where it might not be so.
It might not be so obvious, or things have been exaggerated. Saturation has been increased or decreased or whatever. Or in some cases, sometimes there are images taken that are black and white, and they are then colorized. But I would say, that Mars does look red. Some bits of it look more red than others, though. It's very tempting and easy when we think about other planets, because we have no real experience of them, to just think Mars is a red planet, it's red and sandy.
Yes. Yeah.
And that is what Mars is. But actually, you know, it's an entire planet.
Yeah.
Any one particular, you know, square meter of the surface is not necessarily going to look the same as the one next to it or the one down the road. It is going to be patchy.
Yeah, and there are white bits at the top and the bottom, right?
The ice.
Yeah.
Yes.
Yeah. Which you don't go, oh, Mars, covered in ice.
Yes.
You just assume it's like Tatooine or somewhere and it's just all desert.
Yeah.
Yeah.
Yeah. But yes, it is a reddy browny colour. It contains a lot of iron in the form of rust. So it's rusty red. Yeah.
I guess it looks red in the sky. The other thing I do know about Mars is very dusty.
Yes.
You need a good hoover.
You'd be hoovering for a long time.
So you get a lot of dust storms on Mars, which I don't think I ever want to experience a dust storm.
Well, I wouldn't recommend it.
I feel like you'd get eviscerated.
Not necessarily on
Okay.
Mars, no. There is a recording online of Perseverance rover, being hit by a dust storm. Like the sound of it, because it had its microphone on when it happened.
Deliberately?
Possibly, yeah. I mean, I guess they might have known it was coming, so it's useful to know, because from that and other information, scientists can learn more about these dust storms, and they are a bit of a problem. So knowing more about them and how to deal with them is definitely a good thing. But on Mars, the gravity is weaker. The atmosphere is pretty thin. There's not all that much atmosphere, really.
Yeah.
So, actually, like, the dust being thrown around is not being thrown around with that much force.
Oh, okay, because it doesn't need to... On Earth, in a dust storm or a sandstorm, the sun needs to get blown through the air, as it were.
Yeah.
Yeah, okay. And it needs to be whipped up to sort of overcome gravity in the first place to get airborne.
Yeah.
But then you've got, like, thick air currents to deal with. And
yeah. You don't really have the same thing on Mars. So, even though on the recording you can hear all the sand hitting against Percy, and you can actually hear some, like, of the individual kind of, not droplets, but you know what I mean.
Yeah.
Which is fascinating. It's probably not going to be as bad as it sounds, because we're used to things on Earth, and the idea of being caught in a sandstorm is absolutely horrific. I mean, I'm not suggesting you fly to Mars to get, exfoliated in a dust storm, but it's probably not as bad as you would imagine it to be from your experience.
Yeah, because again, I'm thinking that Mars is basically Earth, but it's very different.
Yeah. Also, you would be in some sort of spacesuit. There is no way you're walking around on Mars as you are. So,
not with the carbon dioxide. Jeez. I guess, yeah. So it's not necessarily too much of a worry that you're on Mars in your spacesuit and your visor gets, like, what's the word? Exfoliated. You don't need to worry too much about wear and tear of your... I mean, I guess you need to worry about these things always a little bit, but,
Yeah, I think probably they're fine with some anti-scratch spray on their visor, which, NASA's got plenty of.
Yeah.
So,
yeah.
I don't think it would be... Like you say, you got to be aware of these things, but I don't think it would be a massive problem for that kind of wear and tear. It is a problem for other things.
Okay.
Like the many rovers that we have sent to Mars. We typically rely on solar panels for the electrical power for rovers and things like that. There are other things you can go with, but it's, solar panels are pretty cheap. They're very effective in that they, there's an endless supply of energy. They're pretty light by comparison to other things. A very popular option.
Yes.
And a very sensible option.
Yeah.
But not so great if you are on a planet where dust gets picked up from the ground and chucked around all the time.
No.
I don't want to say it's a massive problem, because space agencies have dealt with it spectacularly, still opting to use solar panels on the rovers, and rovers still lasting a pretty long time, but it has caused problems.
Yeah. Yeah. You can just sort of see the rover being sort of half buried in sand and unable to move, and its panels are covered in dust, and so it's not getting enough light anymore, and slowly its energy levels are just draining, and it just can't. There's nobody to get out with a shovel,
Yeah.
The other way.
Yeah.
Yeah. I think Beagle 2, the British lander that we don't talk about, because I think that might have been the last time that Britain tried to do anything and it didn't work. I think they eventually found where it was and what had gone wrong, and I think it was like a lander that was meant to have 4 arrays of solar panels, and only 2 of them deployed, I think, because of the where it had landed, something like that. It was like in shadow or underneath a cliff or something, I don't know. So it couldn't get enough power and just never worked. It's just...
Yeah, deploying and opening up solar panels is always one of the nerve-wracking moments in these things, because we're reliant on them working. If they don't work, you don't get power. If you're lucky, that causes lots of problems. If you're unlucky, you get nothing. You've spent all of that money and time and energy, and the mission fails before it starts.
I think that's one of the things that I sort of hate about space exploration, and that, first of all, they announce they're going to do something years before they do it. When they do it and they launch, it then takes too long to get there. Then when they do get there, it's like it might not survive, and there's the sort of...
it's such an instant generation.
It's just like it... I just need instant gratification. But it lands, and it's like, can we talk to it? Yeah, we can talk to it. Can it move? Yeah, it can move. They just like have to test everything, and it's like, if one of those things, particularly important things, if your rover doesn't move for some reason because that got damaged in its landing, it's not a rover anymore. It's just a stationary laboratory.
Yeah. They do tend to build backup things where possible into them, plan Bs, because there need to be. They also employ a huge number of very creative people who can often find solutions from a distance that you I couldn't think up, some of them really are pretty clever, but yeah, it can happen. I think, especially with the first few things, can we get power? Can it talk? Can it move? They're the main ones.
Yeah.
If your other instruments are damaged, then you're pretty bummed, but...
Yeah. But it's not so bad because it's like, well, we now can't take soil samples, but at least we can still, like, take images or something.
Yeah, and the reality is that it's reasonable to expect that there will be a problem.
Yeah.
Sometimes they can fix that, they can patch it, they can find a workaround, whatever.
Yeah.
And sometimes they can't. You just have to hope that the thing that doesn't work is not one of the vital operating functions.
Yeah.
Which is how all science and research works.
Yeah.
There'll be at least one bug in every bit of code I've ever written.
Mm-hmm.
You just have to hope that you've done enough tests that whatever the bug is, it's not that important.
I'm also glad that I am not the person behind deciding where they move in a given day, because I just feel like how much... Can you imagine if you were the person that sort of typed in, like, or, decided, we're going to go over this way today, and then it's like, oh, it's fallen into a chasm, or, like, it's underneath a cliff and it's run out of batteries.
They move incredibly slowly. Like, incredibly slowly.
So there's no worry. It's like, it's going over a cliff. We've got 2 hours to stop. Is it that kind of thing?
Yeah. I mean, I think it would be highly unlikely that would happen. Yeah. Although I don't think NASA's going to call on you to drive any of their rovers anytime soon, or any other space agency. I don't think you've got the qualifications. So.
I mean, I can't drive on Earth, so... But then I guess you don't need a driver's license to drive on Mars?
I'm not sure a driver's license makes any difference. The ability to drive a car will not influence your ability to drive a rover.
Oh, can you imagine though? Do you get like a special driver's license? It's
No.
like you can drive cars, tractors, motorbikes, and Mars rovers.
No. Maybe you just write it and show it on the back. I don't know. But yeah, that's dust storms. They're also pretty interesting though, in that the movement of the dust, being blown about, creates a lot of electrostatics.
Like rubbing a jumper, a balloon on your jumper.
Yeah. Going down a plastic slide at the park with your woolly jumper on. All the static shocks you used to get as a kid.
I do not remember that.
Really? Oh, yeah. I used to get so many.
Maybe I didn't wear jumpers.
Oh, maybe. Or maybe you had really thick rubber things on soles on the bottom of your shoes. I don't know. Anyway, there's a lot of electrostatics generated by the dust being whipped around, and it will spark to discharge.
Okay.
And it's thought that this would make kind of like purpley glows of the dust clouds.
Okay.
Which is pretty cool.
That is cool.
Pretty funky. And it's been referred to as being similar to St. Elmo's fire. Which
St. Elmo's fire.
You know more about this than me, so I'll let you have your little excitement.
So it's some weird stuff about sailors going around, and then I think it's almost like lightning strikes the mast of the ship, but it's not really lightning. It's sort of weirdly coloured lights, but it's the same sort of thing going on. I'm not sure if the light is related to the the gases in the air, or I don't know if it's sort of like
the colour of the light.
Yeah,
right.
I don't know. It's also a song. It's like an 80s power ballad.
Okay, interesting.
I don't know. You might know more than me.
I might know it if it was playing, but...
Yeah.
Yeah, I read it was, the mast going through the clouds and causing discharge to occur as it passed through. I didn't see what colour it was or anything, but it's interesting, pretty cool. A purple glow in Martian clouds, dust clouds. It's pretty atmospheric and sci-fi, I would say.
Yes.
So yeah. But these discharging dust clouds have also been mentioned as potentially contributing to the production of things in the atmosphere, such as perchlorates.
Okay.
Which apparently don't like organic material.
Yeah, I think it's not that far off bleach, I think. So...
delightful. So yeah, a potential thing to be aware of visiting Mars.
Yeah.
Probably any potential life that could have been there once upon a time might not have liked that either. Or maybe it learnt to love it though, because life finds a way.
Oh. So the other thing that Mars is known for is the largest mountain in the solar system.
Yeah.
Which is not the face. You know the picture of the face on Mars? It's like, oh, it's a face.
Oh, I'd forgotten about that, yeah.
Yeah. And then they took some more pictures and like, oh no, it just looked a bit like a face that one time. It's not aliens, don't worry.
No one ever... Oh, no, it's not aliens.
But Olympus Mons is not the face.
No. It's an extinct volcano.
No. 3 times the height of Mount Everest.
Yeah, it's pretty big.
It's also...
pretty wide as well.
Yeah, really wide.
Yeah.
But when you see a picture of it next to Mount Everest, not only is it significantly higher, it's also much wider.
Yeah.
Also, what I find crazy is, due to us not really knowing that much about the outer solar system, a lot less than we would like to think, Olympus Mons is the highest known mountain, because there are some things out there that maybe there are taller things. Just don't know.
Yeah, I mean, it's unlikely that there are any on the other planets.
Yes.
Gas planets are not ideal places to find mountains.
Gas mountains.
Yeah. But there are plenty of rocky moons.
Yeah.
Out there. And to some extent, the smaller your object, the easier it is to get a big peak.
Mm-hmm.
Gravity is smaller.
Yes.
So you can get a taller mountain. That only extends a certain amount
Yes.
of the way, though. However, obviously, once you've got a teeny tiny object, you're not going to get a massive mountain.
Otherwise, 100% of it is a mountain.
Yes.
Which doesn't count as a mountain, I wouldn't say.
No, I don't think that would be accepted.
Oddly shaped moon.
But yeah, so yeah, there is a huge amount about the solar system that we don't know. we feel like we should know it because it's our home and we have spent a decent amount of time exploring it, but there is so much we don't know.
Yeah.
It might not be the biggest mountain in the solar system, but for now, it holds that title.
Yeah. It's also got lots of canyons and craters made from, they think, scientists say, water and lava millions of years ago, gouging things out.
Yeah, both very good at gouging holes in the surface of a planet. So, yeah, some of them are quite spectacular.
Yeah. The Valles, I don't know if that's how you'd pronounce that at all, Marineris.
I don't know. That's how I've always pronounced it, but I don't actually know that's...
Well, I always thought that it was, or whenever I've seen this name, I always thought they'd just taken the Mariana Trench and spacified it. But actually, it's named after Mariner 9, which was the first orbiter to take a picture of it in the 70s. So it's actually like Valley of Mariner 9, as it were.
Happens quite a lot. It's quite common for locations to be named after probes or rovers or whatever that discover them or have some significance to them.
Yeah.
Yeah, which is a nice touch, I think.
It is. But it's 4,800 kilometres long, or 3,000 miles, which, if you put it on the globe, would be about the same length as stretching from the western US seaboard to the eastern seaboard. So right across the mainland contiguous United States. And it ranges between 7 and 320 kilometres wide, so quite a range. That's 4 to 200 miles in width. And
that is a big range.
Yeah, and up to 7 kilometres deep in places, which is 4 miles or 23,000 feet. Yeah. And it seems like maybe it was tectonic plate activity and it sort of cracked open, and then over time with, I guess, those sandstorms, it's been eroded into more of a feature. But yeah.
Yeah, it's interesting. I almost called it Earth science, but Mars science.
I was going to say geoscience, but that's all.
Geoscience suffers the same fate, but that's what it is. It's interesting seeing the geoscience of other planets. I suppose it's planetary science, but it doesn't quite work. I guess there are a lot of departments these days that are the geoscience and planetary science departments, so maybe that is how they like to be referred. But it's fascinating because Mars is pretty different from Earth, but in many ways it's similar. It's a rocky planet, got a core, got a mantle, got a crust. Once upon a time had more of a similar structure to Earth. But, all in all pretty similar, and therefore tectonic plates and similar kind of behaviours, at least once upon a time. And it is interesting, all of that, to me at least, because a lot of the kind of overall behaviours are similar, but then, it's not all identical because Mars isn't composed of exactly the same thing as Earth. So, yeah.
And when you change the mass and things like that, then you really do start to change, you change how gravity behaves, you change the temperature of things, you change the whole system. So Mars also has 2 moons.
It does.
Pretty
Phobos
good.
and Deimos. Fear and terror.
Generally, it feels like they pick random things with a theme, but this seems pretty thematic. So they were discovered in 1877 by Asaph Hall. Apologies to Asaph if I'm pronouncing your name wrong. An American astronomer. I think he was Asaph the Third, which is always what you want in a famous person name. But yeah, he named them after the sons of Ares, the god of war. So
Yeah, Ares is just the Greek version of
yeah,
Roman Mars. So it has these two moons. They're pretty lumpy. They're pretty small.
not very
Deimos
moony.
especially is very small. Not very moony.
Yeah, I want a nice round moon. I want one that's kind of like our moon, but not really. They look.
If you're looking for a moon in
Yeah.
the solar system that's like our moon, you're going to be struggling. Most moons are not as big as our moon.
Yeah, I mean, you look at some of the. What was it that Saturn's got an extra 60 odd moons that they've added on now. And a lot of them are just lumps of rock that orbit the planet. Is that a sufficient definition?
That's literally what a moon is.
I know. I just want a nice round thing.
I think there's some beauty in their lumpiness, personally.
Like a funny looking vegetable.
Maybe. But yeah, they're pretty small. Phobos is also set to either break apart or crash into the planet in about 50 million years.
Okay, so we're
not
going to be waiting a
going to
while.
be seeing it anytime soon.
Okay.
But Phobos is going inwards.
Okay.
Deimos is going outwards.
So Mars is going to potentially lose both its moons.
Eventually, yeah. But Phobos, if it does get broken apart, it could turn into rings.
Ooh, well, that would be interesting.
That's how we think a lot of rings around planets form, is by the breaking up of moons. So that would be interesting for Mars.
Another ringed planet in the future. Would that be the first terrestrial planet with rings then in our solar system? I guess Mercury and Venus don't have anything.
We don't know. We don't really know how our solar system has got to where it is. And if Venus had lost a moon by it crashing into the planet, there could have been a period in which Venus also had
rings before it then lost its ring.
System, which were lost by, just by a simple logical thing of that's how we think rings exist, and but yeah, I mean none of them have rings currently, so if Mars were to gain some, it would be the only one.
So you mentioned with Mars, it's got ice. It's got ice caps.
Yes.
So is that why we're obsessed with life on Mars?
I don't know why we're obsessed with life on Mars. I think for lots of reasons, but I think that does come into
it.
Okay. We're obsessed with finding life or evidence of life anywhere. We've been to Mars quite a lot. We like to go to Mars. It's pretty easy to get to compared to other planets. It's a rocky planet. It appears as if it once had lots more liquid water than it currently has. It could have been an alright temperature. It could have had a magnetic field to protect it. There's a lot of... It had a lot potentially going on in its past. So the question of was there ever life on Mars is a very sensible question to ask. It's highly, unlikely that it has any now.
You're right. And is
The
that
conditions just don't seem right. It doesn't.
is that if there is life now, then it's like deep below the surface, or like at the ice caps or something? Or are we like that? Not even that is likely.
Well, we can never say never, right?
Mm.
We really do have to be careful throwing around certainties where life is concerned, because I don't think we really know enough about it, and we're fascinated by it. We all are. How many times have we talked about life
All the
potentially
time.
existing anywhere that isn't here? And a lot of the time it's not planned. We just end up talking about it. It comes up. The question comes up.
Mm-hmm.
It finds a way of being asked. There is evidence of liquid salt water as well, and salty oceans are a quite favoured thing in the research realm of life development there. So it's got that going for it. But there really isn't any evidence of life right now, which I don't think is that surprising personally. But could it have had life? Yeah, I think it could have.
Yeah, I guess it
I
all
think
goes.
there's a pretty high chance.
Always goes back to how did it start off in the first place?
Yeah, that's more the thing for me personally. Is how would it have got there, because it's ticking a lot of boxes for it being a good place for life to have existed for some amount of time.
Yeah.
But how did it get there? I mean, that's the missing puzzle piece in general, isn't it? For our understanding of life is how does it come about? So it makes sense that that's the sticking point, really.
So do you think we'll ever colonise Mars? Or even go there? Humans?
Yes, I think humans will go there.
Soon? Is Elon going? Or are we having to wait?
I don't think Elon is going. Is his company sending people? I don't know. Maybe. I don't know enough about economics to comment on the stability of his business model.
Fair.
I would not be surprised if humans visited Mars in our kids' lifetime.
Okay.
I would like to see it in our lifetime. But I struggle to imagine, too far ahead in the future of what space exploration will be like.
Yeah. Yeah. And when you get there, you've got to stay. You've got to stay a fair amount of time, right? Because
it has to be. It can't be a mission that is rushed into. It has to be really well and truly planned, backup planned. There has to be plan A, plan B, plan C. You're there for a pretty long time. You're going to be there probably for 6 months or whatever, 9 months. You have to wait. Well, you don't have to, but you launch at a certain time so that you're not travelling too far to Mars. When Earth and Mars are as close together as they can be. And ideally, you would launch back from Mars at the same kind of time, right? When they're close together again. Not when Mars is on one side of the sun and Earth is on the other side of the sun.
Yeah. Yeah.
If you've got to do that, then you've got to do that, but you then have to have the fuel available to be able to do it. So...
And I guess also like life support systems and things to provide oxygen or whatever for the flight back.
So you really have to have a lot of backup plans in place because you're going to be there for a long time. It's not really that close, you know. It's close compared to other things in the universe, but you're going to struggle to get anything delivered there as well as getting people back. So you kind of get there and you're kind of on your own.
Yeah.
In a way that no human has literally ever been before.
Yeah.
It has never been that isolated.
Yeah.
And you got to do everything for yourself. You got to provide all of the life support. I don't know if we'll ever colonize Mars. Perhaps we might be driven to do so. But what would the drive be? I mean, colonizing Mars makes more sense than colonizing kind of anywhere else. We're not going to colonize Venus. And everything else is pretty far away.
What about the moon?
Well...
Just no point.
Yeah. It's one thing for it to be a science base and a launching pad to anywhere else. So, you know, for example, if certain stuff could be made or produced or put together on the moon and then launched from the moon, the gravitational force of the moon is considerably less than that of Earth. And so you need less energy, less fuel to get it into space.
Yeah.
There's a lot of scientific benefits of having, you know, a crewed moon base that's pretty permanent. There are, you know, lots of benefits, but colonizing it, why?
Yeah.
Because the only answer that I can think of to that question is because it would be fun, and that's not really a driving force to actually colonize somewhere.
Yes.
And, you know, once we kind of get to applying that to Mars, you find yourself in a similar situation.
Yeah, unless we want lots of carbon dioxide or iron, probably all right.
So there has to be a reason for that to happen, really. And maybe there is one. There may very well be one, but I don't know what it is.
Yeah.
So I don't know if we would ever colonize it.
Also, looking at the sort of history of missions to Mars, there is an awful lot of failure. Like, a lot. Like, especially early on, but even like relatively recent things either completely don't work or they work a bit but not fully. Kind of like we were talking earlier.
Yeah, especially when you're doing things for the first few times and the environment is very alien, literally, to you. It's difficult to plan for things because you don't really know what you're getting yourself into. So things can go wrong. I think people obviously care about their rovers, so I don't want this to come across wrong. But space agencies and people in general will care more and do care more about successfully getting people somewhere and back
And back.
than a rover. I guess what I mean is the loss of a rover is upsetting, and it's cost a lot of money, a lot of time, a lot of emotional energy of the people involved in the project, and they're invested in it. Don't get me wrong, they're very invested in it, but the loss of a rover is not the same as the loss of human life. And people don't... It's not that they take risks necessarily with rovers or space probes or whatever, but things get a lot more checked and a lot more...
Double, triple checked.
And just
backup
plans and fail-safes and everything. Because that is absolutely necessary when human life is involved.
So on that note, have you got any favourite rovers? There's been a few.
Oh, there've been lots. I do have some favourites. I think we all have favourites, but we could just talk about a few in general. Mariner 4, the first successful flyby of Mars in 1965. That's like pretty significant. The Mariner 9 vessel was the first to orbit another planet, so that's also pretty significant, although it was only 2 weeks before the Soviet Mars 2 did the same thing. So, they were both kind of...
Can you imagine
a similar...
If you were behind that Soviet mission, you'd be like so peeved.
Yeah, you've been scooped there with that research paper.
Like 2 weeks.
The Viking 1 was the first successful lander in 1976.
Okay.
It was active for 2,245 sols.
Oof. Wow, that's like 3 Martian years, something like that? But more like, 7?
Which is then like 7 years.
Like 30 years?
Yeah. So yeah, that's good going.
Nice.
What else have we got? Oh, possibly my favourites.
Okay.
Well, I don't know if I could pick a favourite, but we are from the generation of the Spirit and Opportunity rovers. You didn't care, but...
I feel like I recognise the name Opportunity.
Yeah, Opportunity lasted longer than Spirit.
Okay.
They were twin rovers. Landed in 2004, so that's why I feel like it's kind of like Doctor Who. You have like your Doctor.
Yes.
I feel like they were our rovers. And obviously that's not at all how it works, but just like I was at the age when they were doing things that it played a significant, part of my life, if you know what I mean.
Yeah.
So yeah, Spirit did pretty well. 2004 to 2009.
Okay.
So, pretty good going. Especially considering that they were only supposed to last 90 sols.
Okay, and that's more like a lot.
Yeah, a lot. But it got stuck, and unfortunately they tried a lot. As they do with all of these things, because you don't want to lose one without trying.
Yeah.
And in 2010 it ceased communicating with Earth, so unfortunately that was that. Opportunity, however, kept going. Landed 2004, kept going until 2018. I think a lot of people listening to this probably know and recognise Opportunity. It got nicknamed Oppie. It got kind of personified, and I think it was probably one of the first for that to happen.
Okay.
because it was very popular amongst, the people working on it, and therefore it trickled into the media, I think. Because it was kind of the underdog, It was meant to last 90 days, basically. 90 souls.
Yeah.
93 days. And instead it lasted 14 years.
Nice. That's that's good value for money.
Yeah. And it did a huge amount. So that, corresponds to about over 5,100 souls instead of 90.
Is that they set a low bar? Was it like we can't really plan for any more than like 3 months worth because we have it could just run out of battery or whatever, or is that?
I mean, They always will probably set a low bar because they want to make sure that they can get everything done. So they don't want to give themselves too much, and then it's not possible to answer their questions or collect the data that they want. I mean, Mars has had a lot of, like you say, failed or problematic things, and the dust does relate to quite a lot of those, as it unfortunately did eventually for Opportunity. But basically they worked really hard to keep it going. So they would wait until, as soon as they knew there was going to be a storm coming, they'd power down.
Okay.
And try to weather the storm, and did spectacularly for 14 years.
Apparently so.
I think the people there deserve a lot of, respect and credit for it. And they obviously developed a knack eventually in doing it pretty well as well. It travelled 28 miles, 45 kilometres by the time that it finished, which, to be honest, for 14 years is not that far.
Not that far,
But
no.
rovers travel incredibly slowly.
If you travelled at 30 miles an hour, you'd get that done in an hour with a couple of minutes to spare.
Yeah.
So...
yeah, incredibly slowly.
Maybe this is also why I'm not allowed to drive these things.
Toot. But yes, Opportunity was hailed as one of the most successful NASA missions.
Nice.
Did really, really well, but unfortunately in 2018, as probably a lot of people will remember, it hibernated ready for a storm and it never rebooted. They thought that maybe it, the dust got stuck on the solar panels, and they were hopeful that it would be okay because it was going into winter. It was November, and it was going to be super stormy, there was going to be a lot of wind over the coming few months.
They might just blow it off.
And they thought it'll blow it off and it'll be all good, but they tried, I think, like 1,000 times they messaged, and they never got a response. And by the February, they declared it was the mission had ended. They weren't going to try anymore, which was the end of an era, really. It really was. But now we have Perseverance, which, when you look at the pictures, looks like a modern version of Opportunity and Spirit, really.
Nice. Don't change the basic plan if it works for 14 years.
Yeah, if you know that something's successful, then don't mess around with that. Hopefully we'll get lots out of Percy. I felt like Percy had been around for ages, but actually it only landed in 2021, so
Yeah,
that's quite weird. My grasp of time has gone
Yeah.
funny there.
2 years.
But it's already been active for over 800 salts. Has its little friend,
Yeah.
Ingenuity. Ginny.
First thing to fly on another planet.
Yeah,
It's pretty cool.
the video the first time, it was quite exciting.
Yeah.
It's now done over 50 flights, which is really cool.
Jeez.
So I have high hopes that Ingenuity as a prototype will be really helpful.
Presumably that goes faster than a normal rover as well. You know, presumably that's not crawling along in the sky.
No, Ginny goes pretty quickly, yeah, and that's part of the hope for these kind of things, is that they can be scouts.
And then it identifies, like, that looks like an
For
interesting
things.
location over there. That kind of thing. Nice.
Yeah. But yeah, a little factoid for you.
Yeah.
Percy landed.
Okay.
Obviously, has to get down onto the planet. And when it landed, they then named the landing site. It didn't have a name.
Yeah. Nothing had
until
landed
then.
there before.
So it landed. They named it the Octavia E. Butler landing.
Nice. The author, sci-fi author,
Yes.
that I'm partway through reading one of her books at the moment. Although I've not been able to read much for a while. But that actually, not as the main plot, but as sort of flavour. It's also got people are going to Mars.
Oh.
Yeah. It's like the first landings, like human landings on Mars. The Parable of the Sower. But it's actually set in post-climate apocalypse California, so...
So that was Mars. I mean, there's so much, as with all the other planets, there's a huge amount we could say. And we have definitely taken detours
Yes,
in
definitely.
this episode.
Another reason why we're not allowed to drive Rovers. Because they don't take detours.
But it's been fun.
Yeah.
Yeah. It was a nice visit to Mars.
Mm-hmm.
And
Not
maybe
too
we'll
sandy.
come back again one day.
Maybe when we start colonisation. We must have left a lot of, like, rover junk on Mars.
If we ever do end up, colonising Mars and it becoming like a holiday destination or something, I mean, there is going to be a huge amount of history to visit. A huge amount of
go visit.
Space exploration history. Yeah. I think that quite regularly with Mars and the Moon as well.
So would you go and see Opportunity's last resting place?
Yeah.
Well.
I would be interested to see, photos of some of them as well, I don't know, maybe there have been some taken. But maybe that's something that Ginny could do in the future. Not necessarily that particular version, because they would have to be close to the site. But it would be interesting to see, what happened to these rovers. Not just from the point of view of, oh yeah, look, they got covered in sand or whatever, or I don't know, they fell off a cliff because Elliott was driving it.
Yes.
But like, how did they decompose in any way? Is it rusting?
Yeah.
Like, there's not really any oxygen. It's all in the rust already. But
and degradation.
Interesting to see what they are like now. Yeah.
I wonder though if these places are cursed. It's like you couldn't say, let's drive our rover over towards where another rover failed, because it's like, it's a bad place.
That sounds a bit superstitious.
Yeah. I think exploration's got a lot of superstition in it, hasn't it? If you
Possibly.
work at NASA, write in and let us know. Are you superstitious?
And are we allowed to to see the older Rovers? I don't know. Right, well with that, we will part ways until next week.
Yeah.
Thanks for joining us, and see you again soon.
Bye. So that just about wraps things up for this episode. Please, can we encourage you to subscribe to Through the Telescope wherever you find your podcasts, and, if you like, you can leave us a nice positive review as well. It really helps the show and it makes it easier for more people to find us.
Feel free to send us any comments, questions, or suggestions of things or people you'd like to hear about or from in future episodes. Or perhaps to put yourself forward to chat about your own astro research or experiences. As always, you can find us on Instagram at Through the Telescope Podcast, or you can find me at astrophysicist_Rose. You can also find us on Twitter at The Telescope Pod, and you can contact us by email at throughthetelescopepodcast@gmail.com.
And with that, we'd like to thank you very much for listening, and we look forward to seeing you again next time.
Bye.